Now that we've done a review of fractions and working with rational expressions, we've added fractions that have the same denominator. What do we do if they have a different denominator? Well, we got to create a common denominator. So let's go back to the old days with just numbers before we start throwing variables into the mix. What'd you do when you had a 1/5 and a 2/9? You had to find a common denominator between 5 and 9. So you started looking for factors that they had in common. In this case, they really don't have anything in common, right? A 1 and a 5, a 1, 3, and a 9, no common factors. So between a 5 and a 9, I'm just going to multiply them together and get a common denominator of 45. To get a 5 to become a 45, I got to multiply by 9. But if I multiply the bottom by 9, I got to multiply the top by 9. 9 over 9 is 1, so you can multiply top and bottom by the same thing without impacting the value of the fraction. So I end up with a 9 over 45. How about over here? 9 times 5 is 45, so multiply top and bottom by 5. 2 times 5 is 10. 9 times 5 is 45. Now add them together. I get a 19 on the top, a 45 on the bottom, and that's as simple as it gets, right? 19 is a prime number, so we really can't simplify that. How about the second one? Second one's a little bit different. It's got a 6 and a 9. Could I multiply them by each other? Sure, but factors of 6, 1, 2, 3, and 6. Factors of 9, 1, 3, and 9. So my answer is going to have a factor of 3 in it somewhere. I bet you it also has a 2. Another way to look at this is to start with the 9 and start going up by multiples of 9. How about 9 times 2? Oh, 9 times 2 is 18. 18 is divisible by 9, and 18 is divisible by 6, so it looks like the least common denominator is 18. Which I could also get, by the way, by taking that 3 and the 3 and the 2, multiplying them together, right? 3 times 3 is 9, times 2 is 18. The highest power of 3 that I have is in that second term, so that second term has a power of 3 squared. This one has a 3 to the first, so you take the highest power, and I'll do it in the next slide when you find the LCD. All right, what do I need to multiply 6 by to get 18? I need to multiply by 3. What do I need to multiply 9 by? I need to multiply by 2. And again, whatever you do to the top, you got to do to the bottom, otherwise you're changing my fraction. All right, so 3 times 1 is 3, 3 times 6 is 18. Notice that if I had taken 3/18 and simplified it, I'd get back 1/6. Over here, 4 times 2 is 8, 9 times 2 is 18. Again, 8/18 and 4/9 are equivalent fractions. Now add them together. I got 11 on the top, 18 on the bottom. Now, what if I had just done 9 times 6 and gotten 54? Is that wrong? No, it just makes the numbers bigger. So instead of dealing with 18ths, I'd be dealing with 54ths and much bigger numerators. And then what would happen is when you got to the next to the last step, you would end up with, 33 over 54, and you would be able to simplify it, and you'll end up back with 11 over 18. All right, so if you want to find the LCD, there is a process. Factor things into primes, list them out, and then it's the product of the factors raised to the highest power. So if you want to do that process with the 6 and the 9 that we did before, 6 is equal to 2 times 3. That's what we call a product of primes. 2 is a prime number, 3 is a prime number. 9 is equal to 3 squared. Okay, I factored it down to its primes. So it's the product of the factors raised to the highest powers that appear in a term. So there's a 2 in the first term, there is not a 2 in the second term. 2 to the first. Look at the 3's. There's a 3 and there's a 3 squared. The highest power is second degree. So that gives me 2 times 9, which is 18. So the LCD of a 6th and a 9th is an 18th. All right, this problem just asks us to find the LCD of each one. You notice there's no addition or subtraction sign, there's just a comma. So here are two fractions, find the LCD. All right, for each one, we'll start with the constants, if there's any, and then we'll work through the variables. So the first one's got a 4 and a 5. No common factors, so I'm going to have to use 4 times 5, which is 20. Look at the x and the x squared. The higher power is the x squared, so we go with that. Same with the y and the y squared. So 20x squared y squared is my LCD. Look at the next one. Those things on the bottom look factorable. So let's factor out an m, and I'm left with an m minus 4. Over here, I need factors of 8 that add up to -6. So I'm going to go with -2 and -4. Foil it out, and it looks like I'm right. So notice that they both have an m minus 4, so I'm not going to duplicate it. The first one has an m and an m minus 4. The second has an m minus 2 and another m minus 4. All right, well, I don't need to repeat the m minus 4 that's already there, so there's my answer. If somebody says to write it out in standard form, all right, then I got to foil it out, but I think this is good enough. Right, third one would be the same thing. So this one says add, subtract, and simplify. For the first one, we're going to multiply top and bottom by x. So that'll give me a 6 over x squared plus 4x over x squared. Now I've got a common denominator. Can't add them together until I get a common denominator. Once I have a common denominator, nothing changes. The denominator just stays there, right? It doesn't become like a 2x squared or something. What we add is the top. We add a 6 plus 4x. And that's as good as it gets. All right, take a look at number 3. First thing I'm going to do for number 3 is I'm going to factor the bottom, because I can't come up with common denominators and least common denominators until I have some idea of whether factors repeat or not. So this becomes an x plus 2x plus 3, right? Foil it out, I got an x squared plus 5x plus 6. Over here, I have x plus 3 times x plus 1. Foil it out, and I do get x squared plus 4x plus 3. So when I build my common denominator, I'm not going to repeat that x plus 3. I'm just going to multiply the top and bottom of the fractions by what is missing, essentially. So in that first term, what's missing is the x plus 1. So I'm going to multiply this thing top and bottom by x plus 1. So now I have x plus 1, x plus 2, x plus 3. What's missing in the second piece? It's the x plus 2. So if I multiply the bottom by x plus 2, I got to multiply the top by x plus 2. Now you notice that I have a common denominator of x plus 1, x plus 2, x plus 3. The rest of this is just multiplying and simplifying. So look at these first two terms, the x plus 1 times x minus 4. Foil it out. So that gives me x squared minus 4x plus x is minus 3x minus 4. Now look at the second terms, the 5x plus 6x plus 2. This is nice because there's a plus sign in between, so we say plus 5x squared. 5x times 2 is 10x. Plus 6x makes plus 16x. Plus 12, all over our common denominator of x plus 1, x plus 2, x plus 3. All right, now let's simplify that top. X squared plus 5x squared is 6x squared. 16x minus 3x is plus 13x, and 12 minus 4 is 8. On the bottom, I have x plus 1, x plus 2, x plus 3. All right, so at this point, then, I have to make a decision as to whether to simplify or to factor that top, and if it's even factorable. So I'll be looking for factors of 48 that add up to 13, and I can't think of any combos that work. Factors of 48 would be like 1 and 48, 2 and 24, 3 and 16, 4 and 12. I'm not coming up with any that add up to 13. So I would factor the top if it was factorable to see if it canceled with anything on the bottom, but it doesn't. So that's my answer. All right, the trickier ones are the ones like number 4 that have a minus sign in between them. If they have a minus sign, then you got to remember to subtract everything in the second term from the first term. So let's give that first one a try. First thing I think is the F word, factor. So x squared minus 16 factors as x minus 4x plus 4. The second one factors as x plus 4, x plus 1. So I notice that they both have an x plus 4. What terms are missing? Well, in the first one, what's missing is the x plus 1. So I'm going to multiply top and bottom by x plus 1. Over on the second term, what's missing is the x minus 4. So now I got a common denominator of x plus 1, x plus 4, x minus 4. On the top, x times x plus 1 is x squared plus x. Now, we've got to remember that there's a minus sign here. So the minus sign gets distributed too. So negative 6 times x, negative 6x. Negative 6 times negative 4, positive 24. And now combine like terms. So this gives me x squared minus 5x plus 24 all over x plus 1, x plus 4, x minus 4. All right, can I simplify that top at all? I'd be looking for factors of 24 that have the same sign and add up to negative 5. So negative 6, negative 4, that does not add up to negative 5. Negative 8 and negative 3, that adds up to negative 11. And I can see that the numbers are getting bigger. So I'm going to go with that top doesn't simplify. All right, what happens in number 6? Number 6 looks a little funky. It's got an x minus 4 plus a fraction. Well, this x minus 4 is really over 1, right? So my common denominator is really just 2x plus 1, but that means that I need to multiply the top and bottom of this thing by 2x plus 1. So a 2x plus 1 there, and a 2x plus 1 there. So let's clean this up a little bit. That means I've got a 2x plus 1 times x minus 4 over 2x plus 1 plus a 3 over 2x plus 1. So I don't have to touch that second term. It's already got the 2x plus 1 common denominator. What I have to do now is multiply that top. So 2x times x is 2x squared. 2x times negative 4, negative 8x, plus x minus 4, plus that 3 from the second term. All right, clean up the top. 2x squared minus 7x minus 1 over 2x plus 1. And so now, I could look and see if I can find factors of negative 2 that add up to negative second. That's a quick no. There's my answer. All right, let's run through a couple more of these. Look at number 2. I've got an x minus 1 and a 1 minus x. Now, I could multiply the first one by a 1 minus x and the second one by an x minus 1, but you realize that these are pretty close to each other, right? A 1 minus x, isn't that the same thing as negative positive x minus 1? So what if I rewrote the problem as 4 over x minus 1 plus, instead of putting that negative on the bottom, let's transfer it up to the top. Make it negative 3 over x minus 1. And now look at this. 4 plus negative 3 is 1 over x minus 1. Right, so make things simple if possible. Look at number 4. Number 4 is a subtraction problem. Sometimes subtraction problems are a little bit tricky, so we should work our way through this one. Factor x squared plus 6x plus 9. Hey, that's a perfect square trinomial. It's x plus 3 times itself. Over here, x squared minus 9 is x plus 3 times x minus 3. So they already have a common factor of x plus 3. The first one is missing the x minus 3. The second one is missing another x plus 3. So just one x plus 3 is not enough because the first one has 2. So this one over here is missing the x minus 3. And this one over here is missing the other x plus 3. And we have to remember that that negative applies to the second term. So our numerator becomes 6x minus 18 minus 5x minus 15 over x minus 3, x plus 3 squared. So 6x minus 5x is x. Negative 18 minus 15 is negative 33. And there's my answer. And there's clearly nothing I can simplify. Right off the screen, look at that. All right, one more. What happens if I'm trying to add two terms that are like this? 1 over r plus 1 over s, and then find the reciprocal of the result. Sometimes you find odd things like that if you're dealing with electrical systems and you're trying to figure out resistance and voltage and stuff like that. You end up with funky-looking fractions. So sometimes we might want to find the reciprocal. Now, when you go to find the reciprocal, you can't just flip over the terms individually. To find the reciprocal of the sum, first you have to add them together, then flip them. So our common denominator is going to be rs, which means we got to multiply the first one top and bottom by s, second one top and bottom by r. So we get s over sr plus r over sr. And we add them together, we get s plus r on the top and sr on the bottom, or rs, same thing. So then the reciprocal, flip it over. So the sr goes on the top, the s plus r goes on the bottom. And that's it. You can't separate those, right? The s plus r is a sum, so you can't separate the sum. And there it is. That's your reciprocal. So that's what we do when we have to add and subtract with denominators that are not the same. Find a common denominator. And then especially if you're subtracting, don't forget to distribute that negative to the second term.